Hello, thank you for watching this office hour recording. This is Mrs. Tan. Today we are going to talk about the content of the Ferris wheels. I'm going to discuss in detail how to calculate all kind of questions related to Ferris wheels. And also we will go through a few questions that will help with your test. Let's start. If you want, you may download the PowerPoint by clicking the 2016 March 7 Ferris Wheel and Test Review link, and then you click Browse to. You can browse to that PowerPoint. So let's get started. I hope you have checked your email and also watch all the news items. Look at the news item to check the updates as always. Log into your Georgia Virtual School emails every day. There might be some extra credit there. There will also be one extra credit at the end of this PowerPoint. Alright, just a quick review. Not sure how much knowledge you have about unit circle. Unit circle is a circle with one on each axis. Okay, it's only one unit, and it's like any xy points. The unit circle could be, it has 2 pi and pi. And also there are more explanation here that we are going to look at. If you want, you can click on this link and we are going to look at it on a web page together. So here's a unit circle. The unit circle is a circle with a radius of 1. Being so simple, it is a great way to learn and talk about length and angles. It's used in trigonometry a lot, and the circle is put on a graph where the x and y axis cross. So it starts where the origin is. So we get this neat arrangement here. Because the radius is 1, we can directly measure the sine and cosine and tangent. Okay. We will also have a quick review of sine, cosine, tangent from here in this office hour recording. So I will leave this. Unit circle is not a main focus for this content. However, I just want to give you a quick overview what it is. And I have posted some tutorial videos. And here, remember unit circle. Okay, please check out our user links here. There are new tutorial section and also helpful websites. If you have any question regarding Brightspace, you should click on Brightspace, an online graphing calculator, and a student handbook are here. So please check out the news item every day. So now we will move on to the next part. The 3 basic trigonometry ratios, which is sine, cosine, and tangent. Sine of a theta, which is the angle, okay, is a ratio, sine of the theta is a ratio of the opposite side of the right triangle to the hypotenuse, and cosine of the angle referred to is the adjacent side, adjacent right next to it, to the hypotenuse of the right triangle. Tangent of the theta is opposite side over adjacent. So in short, we have this short saying so, ka, toa to help you to remember the ratio of these three trigonometric ratios. Today, we are going to use the cosine theta to help us to solve our Ferris wheels questions. These questions is taken from the content that is provided in this course for you. And I only want to break it down because by looking at the content, I consider some of the students might not understand it. And I'm hoping breaking it down here during this session will help more students to understand it. And at any time after watching these videos, you still don't understand, please let me know. I will try my best to explain to you. So let's read. If you haven't read the content, you should always go to the content and read the content. And this is from the content. On February 11th, 2008, Singapore opened a new observation wheel called the Singapore Flyer. At the time its opening, this giant Ferris wheel was the tallest in the world. The Singapore Flyer consists of an observation wheel with a diameter of 150 meters atop a boarding terminal, giving the structure an overall height of 165 meters. Only the platform itself is 15 meters. 15 meters is tall. Okay. 28 air-conditioned capsules rotate on the outside of the wheel to provide unobstructed views of the city. The wheel rotates at a constant rate of 26 centimeters per second. This is slow enough that the wheel does not need to stop for loading and unloading unless there are special passengers needs. Describe how they will calculate the capsule height above the ground. Draw and label your diagram. An accurate diagram of a wheel showing dimension given above. Okay, so we know the total height is 165. This is total height. And out of this height, 15 of them right here, this is a boarding terminal. And the diameter is right here. This is the diameter of the Ferris wheel, which is 150 meters. Okay, so now we are going to describe how they will calculate the capsule height. We want to calculate, at any minute, how tall is each capsule height from the ground. That's our goal of this activity. Alright, Ferris wheel content. So continue. At time 0, the capsule is in a boarding terminal. How high above the ground is the capsule at this moment? So, if it's at a boarding terminal is right here. So how high it is from the ground? It's pretty simple. It's 160 meters, the total height. Subtract the diameter, that give you 50 meters. At 1 minute, how far has the capsule traveled around the circumference of the wheel? Given the information, let's see. So what it means is we want to calculate, let me see. Let's change to red. Okay, if after 1 minute, let's say after 1 minute the capsule got here, right? We want to know how far is it from the ground. We want to know this. Okay? And we are going to be able to figure it out. Let's say this is a capsule using a right triangle that I'm going to show you the next page. Okay? But since the wheels rotate at a constant rate 20 centimeters per second, given a problem, and there are 60 seconds in a minute, we know that at each minute he has traveled 15.6 meters. So this is how we calculate. Okay? Because since we want to calculate 1 minute, right? How far the capsule has traveled in 1 minute. We want to know, like, okay, how tall it is. So we want to know how far it had traveled around the circumference. Okay, and we know that the speed is 26 centimeters per second. So using that information multiplied by 60 seconds, we know it has traveled 1,560 centimeters. Or when you centimeter to meter, 1 meter is equal to 100 centimeter. Okay, so that given that 1,560 centimeter become 15.6 meters. Okay, that's only around the circumference. That's not the height of the capsule from the ground. What we had just calculated is only around the circumference right here. Okay, but we actually need to find this height right here. So let's look at the picture. What is the height of the capsule from the ground given after a given minute? So this is further illustrate what we're talking about. Here's the ground, and this is the height of the capsule from the ground, and we want to look for this. Alright, so here's our strategies. Okay, notice the right triangle you can draw within your diagram. Okay, let's say this is a capsule right here, and connect where the capsule is to the radius, you know, and then this right here, this line right here is the hypotenuse of the right triangle. Okay, this line right here is the hypotenuse of the right triangle, and that is also the radius of the circle. Okay, so if this is 75, meaning this is also 75 right here, this length right here. Okay, and where's the right triangle? It's right here. The right triangle is right here. Okay, and the theta, the angle that we're looking at, which is the angle, the central angle where the capsule is traveling, we want to know how far has it traveled. It has traveled this much. This is the angle that we're looking at right here. Okay, and we call it theta. First, we need the angle of the rotation. We need to figure out what the angle is. And then we will calculate the total time it takes to rotate one circle. Then you use it to calculate the angle. Okay. Second, we will calculate the vertical leg of the right triangle, A. We'll calculate this side right here. Okay, we calculate this side right here. Third, to get the total height, we will subtract A from the radius and then add it to the height of the platform. So since we know this whole thing is the radius, okay, and after we calculate A, we will subtract it from the radius to get this part right here, this black part, and then we add it to the platform 15 to get the total height right here. Okay. If the angle of rotation is greater than 90 degrees, then you will need to add it to the angle of rotation. Okay. View in the table below showing the height. These are all from the content. Showing the height of a single capsule changing as it rotates counterclockwise from the boarding terminal around the wheels. To do this, first calculate the circumference of the wheel. Okay, so the circumference formula is 2 pi r, and we know the radius is 75 because it's half of 150. So you enter in your calculator, you should get 471.24 meters or 47,124 centimeters. Okay. The reason we need a centimeters because the speed of the capsule was given in centimeter per second. Okay, so we want to know how many minutes does it take a capsule to make one complete revolution around the wheel, round to the nearest minute. Explain the process. So the wheel is traveling at 26 centimeters per second, and the distance it must travel is 47,124 centimeters. So using our most basic formula, distance equal to rate times time. The rate that was given is 26 centimeters per second. You put it right here. And the distance is the whole circumference because that's what we calculated. And because the distance equal to rate times time, now to get the time, we use distance divided by the rate. Okay, so distance divided by the rate, distance divided by rate. And you get 1,812 equal to the time. And that's in second. The reason it's in second because the rate is in second. So there are 60 seconds in a minute. You convert it into minutes, you get approximately 30 minutes. Okay? So the reason we convert it back to minute because the question was asked in minute. So here's the first step. We are getting the angle of rotation. Okay, before completing the table, explain how the angle values provided in the tables are correct. This is what's stated in the content. Okay, if a wheel takes 30 minutes to make one complete revolution, okay, so if you start right here, for you to go back down to the ground, it takes 30 minutes. Then 1/30 of the circumference is passed through each minute. Therefore, a single capsule that had rotated 1/30 of 360 of the circle, or 12 degree. Okay, so this is 360 divided by 30 minutes. You get 12 degree per minute. Okay, that is the central angle. That is the central angle that we were looking at. Just now we were looking at this. Let's say this is capsule after 1 minute. This is angle right here that we're looking at, right? Imagine there's a right triangle here, and there's a right central angle is 12 degree. So right here, that's the angle right here that we're talking about. Okay. Now, so here I pull the table out from the content. So this is from the content. The first inscribed angle that models the situation after 1 minute is shown. Use additional diagrams and inscribe right triangles to determine more values of the total height as the given capsule continues to rotate through one complete revolution. Use trigonometry to calculate the corresponding values of A and complete the table, finding the height of the capsule at a various interval of time. So, meaning complete the table, okay? The first minute, we know the angle is 12 degrees. So if the angle is 12 degrees, how are we using cosine to calculate the vertical leg of the triangle? We know cosine theta is equal to adjacent over hypotenuse. And here's my my triangle. Let's draw. Right here, my theta, okay? Okay. Okay. So this is theta. My opposite is right here. This is my opposite. This is my adjacent. This is my hypotenuse. And the A, the length that we want to calculate is the adjacent side. Okay, so since we know using the formula, okay, cosine of the 12 degrees, okay, here's the 12 degrees, is equal to adjacent, which is the adjacent side right here, over the hypotenuse, which is 75. Okay, the hypotenuse is the radius of the circle, which is 75. So, using your cross multiplied, okay, so A is equal to 75 times cos 12 degrees. You use your calculator, find the you should have a scientific calculator should have a cos. So cosine 12 degree multiplied by 75. Make sure your calculator is set to degree and not radian. Okay, then you should get your answer. Okay, as a 73.36. $73.36. The answer here. Okay. So using that, we are going to move on to calculate the total height of the capsule M. And we know that we just calculate 73.36 for this height right here, right? We just calculated that. And the platform height is 15 meters. So now we need to figure out this pink height right here. Okay. So to get to the pink height, I use the distance, which is the radius, subtract my 76.36. So I got this pink height, and then I add it to the 15, I get my total height, which is what label here, which is how tall is my capsule from the ground. Okay, so diameter subtract A plus platform height, then you will get your total height from the ground. $16.64. This is just the first angle. For first minute, your capsule is 16.64 meter from the ground. All right. So now, if to fill out the rest of the number, you know the first minute is 12 degrees. The second minute will be 24 degrees, which is 2 times of 12. And the third minute will be 36 degrees. And you just keep multiply 12 until you get to 360 degrees, which means you came back down to the ground. And then the same way to get the rest is cosine of 24 degrees and then you use same process. You get 75. I just type. Subtract your answer that you got. Okay, then plus 15. And using this process, you should be able to get all the answer on the table that is already shown in the content. All right. So next part of the review or extension of the explanation that I'm going to show is a quick intro or review of science transformations. You need this information to help you to do well in your test and quiz. The sine function can be transformed, meaning it could make it big or small, taller, shorter, or move left or right by changing the parameters of the functions. There are 4 parameters that you can change. The first parameter is the number. It's called like the coefficient of the sine function, a number in front of the sine functions. Okay, that number stretches or squeezes the graph up and down. It stretches the graph up and down if a is greater than 1, any number greater than 1. It squeezes the graph if a is between the numbers 0 and 1. Let's say 0.5, any number between 0 and 1. It flips the graph top for bottom and squeeze it. Two things, if flip the graph because if a is between 0 and -1, because it's a negative number, and because it's a number between 0 and 1, and it's a negative. So it flipped it and it squeezed it too. It flipped the graph top for bottom and stretched it. Okay, if a is less than -1. Okay, so it's pretty easy to remember. If the number that is larger than 1, it stretches it. If it's a negative number, it flips it. Okay, B is a number in front of the x, okay, or the number in front of the domain. If the domain is in a radian, which is in pi or 2 pi or pi over 3, then that is the x that we're talking about. That is the input. Okay? The number in front of the x stretches or squeezes the graph left and right. Okay? So if b is greater than 1, it stretches the graph. If b is between 0 and 1, it flips the graph left for right and stretches it. If b is between 0 and -1, flips the graph left for right. It's like mirror, rotate around the y-axis and squeezes it if b is less than -1. And C moves the graph left and right, D moves the graph up and down. And we are going to look at it on the decimal graphing calculator. Hey, why is it not clickable? Let me try it again. Oh, it does work. All right. So here's A, okay? Here's a decimal graph, okay? This is a sine function that I just put in, and I put in a different parameter for us to play with. Okay, if I move my A to see, if I move my A is usually 1. Okay, 1 is a normal number. You cannot have A 0. Then it will just go flat. Usually A is 1, and that's my normal sine function. Okay, if my A is larger than 1, got longer and longer, it stretches it. Right? If my A is less than 1, now it make it flatter and flatter. Right? If my A is negative, see, A is positive. If my A is negative, see, it kind of flips it. Okay. So this is the effect of A. B, left and right, okay? See, it's pulled left and right. And C moving in left or right. It doesn't stretch or squeeze, but it just moves the graph. Now remember, C is usually 0, and because the formula has minus, so when you have minus positive number, it's move the graph to the left. Minus negative number, the graph is moved to the right. Okay? D moving up and down. All right. I hope this help with this understanding of sign transformation. And cosine function also transform, but cosine function is not a focus for this content. However, it's a knowledge that you might want to know. And here's the notes. You can take notes and keep it for yourself to use later. All right. Here's another thing that's very important for this unit. What is a period? Because we're talking about periodic function. Okay, the period is a horizontal distance between two maximum values or two minimum values. To increase the period, there will have to be there would have to be longer time between two maximum values. So, you might come across question, how do I um, make increase the period, increase the value of periods? So you will say, okay, I'll do this slower, something that happened over a longer period of time will have a bigger period. This means it needs to take more time for a wheel to move from the top all the way to around to the top again, from the top all the way around to the top again. Okay. In other words, you need to slow the rate of the Ferris wheel, or slow the rate of your bicycle wheels, or anything that can be modeled by periodic functions. Anything that go and come back, go and come back, the wave, go and come back, go and come back. Anything else, the clock. Okay. Periodic functions. Periodic functions are functions that repeat over and over, or cycle in a specific period. They are also known as cyclical functions. Sine and cosine functions are the most common periodic functions. In this topic, we're looking at sine and cosine functions as a periodic functions. Circle is not. Okay. Here's some example. Any form of sine and cosine function are periodic functions. Examples, if I have changed any parameter of the sine and cosine, or I added stuff around the sine and cosine, they are still periodic functions. However, circle is not a function. So circle, if you come across questions that have circle equations, they're not a periodic function. The circle go into circle, it doesn't keep going, it doesn't go up and down, up and down. You cannot really calculate the period of a circle. But things that go into circle is different than circle function, okay? All right. If anybody was here, I was gonna discuss this, but I can also go through a quick discussion of this. All right, this is a self-assessment. This assessment is very helpful for you to take some time to do it. It is you can get it on the sidebar of the course model. Do them to learn and practice the concept that we just discussed. Okay. So recall from your science class that sound travels in waves. A wave has several important parts. Okay. Its axis of symmetry, where the middle line is, right here, where the middle line is, okay. Let's crest, the tip, the highest point of the sound wave, and also the lowest point of the sound wave. To calculate the period of the sound wave, you calculate the time it takes from one crest to the next crest. To calculate the amplitude, you measure the height from the center line to the highest point, or center line to the lowest point. Amplitude is how loud your voice is. The crest is the maximum height of the wave, and the source is the minimum. And we just talk about this. Okay. All right. Here comes the questions. Mr. Lishifi's math class used a calculator-based laboratory and a microphone to collect the following sound data. Notice that point X, Y, Z are labeled in a graph. Point X is 0.0054 and 6.5, Y coordinate, and Z coordinates. If XZ's each represent a crest, what is the period of the sound wave? Do not forget your units. So the period of the sound wave we just talked about is a distance between two crests, and the unit in this in the x-axis is time, is in second. Okay, and we know the coordinate of x is 0.0054 and the coordinate of z is 0.0076. I mean the x value of it. So the period, I just type period will be equal to the distance of the x. So you just get the x value for z, subtract the x value for point x. You should get as your period. Next question. The frequency of a sound wave can be found by taking the reciprocal of the period. What is the frequency of the sound wave? We got the period, right? 0.0022. The reciprocal meaning 1 over the number. So the frequency is equal to 1 over 0.0022. And if you 0.0022. You get 454, and the unit for the frequency is hertz. Okay? Good. If B represents a throw, what is the amplitude of the sound wave? What is the amplitude of the sound wave? Let's look at it. Amplitude is how high. So if you were to draw a line of symmetry, it will be somewhere here, right? Okay. So the amplitude is the distance from the middle line to the throat. Okay. So but we don't have this middle line, but we have, or it will be like half of this length right here. Oh, cannot draw a straight line. Hard to use it. Half of the distance between the vertical distance between x and y. Okay, and the coordinate y for the y value for x is 6.5 and the y value for y is 2.5. So they give us an idea that the vertical distance of the 2 points is 4. (6.5) subtract 2.5 is equal to 4. The amplitude is half of it. So it is equal to 4 divided by 2, which is 2. Okay. Sound is measured in terms of pressure. So 2 pressure, 2 volume. In a sound wave, the frequency represents the pitch of the sound. The amplitude represents the volume. For the sound wave that Mr. Lesafie's class measures, what is the pitch and volume? We already talked about. The pitch is 545 hertz. Pitch, the frequency represents the pitch, so pitch is 545 Hz. The volume is 2 pressure, or volume 2. What is the amplitude required to produce a sound wave that is twice as loud? The amplitude will be, just now the original amplitude was 2, so to have it twice as loud would be 4. Okay? What is the domain range of the function to model the sound wave? For general sound wave, domain is the time, right? So all positive real number, and the range is positive number. But I have an argument like I think about, depends what kind of pressure you're talking about. You know, if you're talking about just pressure alone, usually just positive real number. If you're talking about relative pressure, which is the change of the pressure, because you look at a speaker. When you see a speaker producing sound, you can see the speaker bouncing in and out. Boom, 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 bouncing in and out, and that changes the relative pressure inside a speaker that helps produce whatever sound is trying to produce, or loudness is trying to produce. So that's a relative pressure. That you can have a negative number. However, just in general pressure, usually just positive real number. Okay. If the sound that Mr. Levacy class measured lasted for 8 seconds and stayed the same pitch, what are the domain range? If it lasted for 8 seconds, since our domain is time, so the time will be from 0 second to 8 second, right? This is and the range. We know the range. The range was the lowest number was 2.5, and the highest number was 6.5. All right. Compare the domain range of the function that models the sound wave, which is this answer, compared to this answer. All the answer in this number 7 are the subset of answer for number 6. Okay, this has to be the subset of this. All right, I hope you answer most of the questions. We have 10 minutes. I'm going to discuss some test review questions. All right. So here's the first question. If you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. You notice that it takes you 120 seconds to make a full rotation around the wheel. Okay, 120 seconds. If the diameter of the wheel is 50 feet, how far have you traveled in 40 seconds? Alright, let's see. The distance traveled in one rotation will be the circumference of the circle. C equal to the diameter times pi. So in this case, since the diameter is 50 feet times pi times pi, then I will have 157.07 feet as my circumference. And 60 seconds will be 1/3 of the rotation. Why 1/3? Sorry, 40 seconds. Why do I type 60? 40 seconds. It should be 40. because the question asks for 40. 40 seconds is 1/3 of 120 seconds. So that's why 40 seconds is 1/3 of the rotation. So you use 157 0.07 divided by 3. You should get this answer, okay? Alright, I hope if you need to slow it down, if you have any questions after I discuss that previous questions, email me, please. Okay, let's see question 2. A Ferris wheel takes 40 minutes to make a full revolution. 40 minutes. What angular distance in degree have you traveled 5 minutes after boarding the Ferris wheel? So 40 minutes to make 360 degree, right? So we want to know how many degree that it travels each minute. So since it takes 40 minutes to go all the way around the circle, which is 360 degrees, so each minute the Ferris wheel is traveled 9 degrees, which is 360 divided by 40. And in 5 minutes, you multiply by 9, 9 times 5, you get 40 degrees in 5 minutes. Alright, test review question 3. Again, you can always pause if I'm going too fast for you because, you know, and you can always call me and email me if you have any question. Alright, I have extra credit coming out at the end. Please don't leave. That will help you. Going through this question will help you to boost your grade. Consider a Ferris wheel which loads passengers at a height of 2 feet above the ground and carries them to the maximum height of 35 feet. What is the amplitude of the function that models the height of the passengers on the Ferris wheel? So amplitude, like I say, amplitude is the distance between the highest point to the middle of the whole thing, right? The Ferris wheel go up and down, and the amplitude is half of the total distance from the very top to the very bottom. Since the diameter of the wheel is 33 feet, because the loading platform is 2 feet above the ground, so 35 subtract 2, get 33 feet. This means that the amplitude of the function will be 33 divided by 2 equal to 16.5 feet. Since amplitude is half of the total height minus the starting height of the wheel, so the amplitude is 33 divided by 2 equals 16.5 feet. Test review question 4. Suppose the Ferris wheel is moving at a constant rate of 10 inches per second. If the diameter of the wheel is 30 feet, how long will it take for the Ferris wheel to make a complete revolution? Okay. If you're not sure what they're talking about, sometimes you can draw it out. Moving at a constant rate of 10 inches per second. And you need to know 1 feet is 12 inches. Since the distance around the wheel, which is the total distance, is the circumference, equal to diameter times pi, and our diameter is 30 feet, so 30 times pi, 94.2 feet. Since it's 10 inches per second, okay, instead of converting my feet into inch, I convert my inch into feet. 10 inches, 12 inches is 1 feet, so 10 inches is 5/6 feet per second. Okay. If you're not sure how I get that, so you do 10 divided by Then you simplified it. Okay. Now, after you get that, 94.2 feet divided by how many feet per second, you'll get your answer in second. Okay. So if when you divide a fraction, you change the operation to multiply, and then you take the reciprocal of the fraction and you multiply them. So 95.2 times 6 divided by 5. And that's 113.04 seconds to go all the way around. And I change it to minutes. It becomes 1.88. So it's about 2 minutes to go around all the way. It's not really 2 minutes, but just, roughly 2 minutes. All right, test review question number 5. A cell phone has a cell phone plan of a small, medium, and large usage. If you're calling 0 to 100 minutes, it costs $5. If you're calling 101 minutes to 500 minutes, it costs $10. If you're calling 501 minutes to 1000 minutes, it costs $19. What kind of function represent the relationship between the cost and minutes? Because there's there is a range of the minutes that you call, and it costs the same, right? So at that range of minute, doesn't matter it's 5 or 10 or 20 or 50. You sorry, that was my baby. So this is a kind of step function. So how does it look like? Here, let's sketch it out. This is sketch. It's hard to draw a straight line in this thing. So let's say this is 50, 100, 200, 300. So it's about 5, 10, 15, 20. So we know that 0 to 100 minutes costs $5. So from 0 to 100 minutes, it costs $5. So whatever minute you call between 0 to 100, it's going to be like this, okay? It's inclusive circle because at 100 minutes, you will be paying $5. And then 101 to 500 minutes, $400. It costs $10. So from here, so at 100 you have open circle because 100 doesn't count as $10, but right after that it counts. So you have an open circle there until 500 minutes. You have closed circle. Okay, and then if you keep going for until 20, it's like until 1000. Now I don't have enough space. You have open circle because at 500 it doesn't count as $19, but right after that it counts at $19. So this is a kind of step functions that we're looking at. So if you here's the extra credit opportunity for everybody who like extra credit. This extra credit opportunity wants you to complete the questions on the next page to earn up to 5 extra credit towards your linear and exponential model quiz. Okay? And you have to save your document right. Your answer document has to be a Word document. You type your questions in there, and then you write your answer. Create a table. Make sure you type all the value correct, and you must save as your name. If you don't have your name, I don't know who turned it in. Ferris Wheel EC as extra credit. Okay, save it as a Word document, please. Upload the document to extra credit folder under Dropbox. So you have to have your name. I don't know who turned it in if you don't have your name. If you get it right and show step-by-step work, you have to show me work how you get all the answer for each and every entry of the table. If there's only answer, you get no extra credit, but extra work for me and for you. Extra work for me, just even to open your Dropbox document. But I would like to see some of your work that have show work and or write with hand neatly. If you do write with hand, please scan your answer. Use smartphone free scanners such as Cam Scanner. And if you don't have a scanner and you don't have a smartphone to do any scanning, take picture in a very bright place. Not too bright, but bright enough. Okay, many times I receive picture that's too dark. I can barely tell what is on the paper. So it's not good for you. If I can't see well, I can't grade. So here is a question. Right? To celebrate the new millennium, British Airways announced in 1996 its plan to fund construction of the world's largest Ferris wheel. The wheels was designed to measure approximately 500 feet in diameter and carry up to 800 passengers in 32 capsules. The wheels was designed to turn continuously and to be slowed enough for people to hop on and hop off while it turns, completing a single rotation once every 20 minutes. Okay, so here's similar kind of Ferris wheel, but it's a different one. Suppose you board the Ferris wheel at ground level. Let T represent the time since you boarded, and H represent the height above the ground. Can you calculate your time and your height in feet in time 0, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25, 30, and 35. Use the lesson I taught earlier on in this session to help you show all the work to earn the credit, 5 extra credit towards your linear and exponential model quiz. Alright, that's it for today. Thank you for watching this whole recording. I hope all the information that I discussed here will help you for your quiz and your test. All I want to do is to help you. And if you have any questions, please let me know over email. My email is located on the right side of the course homepage. And don't forget, this Thursday midnight is the due date. Please look at your schedules to know what assignment is due and work ahead. Don't wait until Wednesday to turn in everything. It is not good. Make sure you look at your content, study before you do any quizzes or tests. Thank you very much and have a great night.